All right. Good morning or good afternoon. We're going to be doing Unit 1, Day 5, types of angles. Um, and I'm gonna, so we're going to do types of angles, angle addition, angle bisectors. Okay. But before we start getting into deep about it, what is an angle and how do we create it and how do we name it? So two rays that share a common origin or initial point called a vertex. So whenever you have a ray, so in this case I have ray HC, right? HC is one of the ray. And then I have a ray HS. HS intersecting at point H. This is called the vertex and it just created an angle. So whenever you have an angle, there are different ways you can name it. The very common one is to name it by the three letters, but the vertex need to be in the middle. So I can name this as CHS, or I can flip that and I can put SHC. I can name it as angle H, but you have to be careful when you're naming it by that vertex. It has to be that only vertex. I can't have uh, angle H representing two different things. Or sometimes I can just use the number that they gave us. So in this case, they gave us number 1. So I can also name this angle 1. Okay, that's something we're going to talk more about it. So notice that the vertex SH is in the middle letter of the three names. If you switch it around and say HCS, for example, you're naming an angle that is being created here, not this one. Okay, so if you make C in the middle, that means that's the angle you're talking about. If you make S in the middle, this is the angle you're talking about. So you just have to be very careful how you name your angle. All right, so when it comes to an angle, it shows here that we need an angle is measured in degrees, and this is what the symbol you use using the tool called, you guys know that, protractor, right? Okay, the number is based on how much of the circle the angle marks, with the full circle being 360. Okay, so think of it like a clock. So I have a protractor for the tools here, so I'm going to show you what it looks like. So it looks like this in what a protractor is for those who haven't seen it before. I don't think there was, but it all depends what kind of background you have. So this is a protractor. So if I want to measure this angle, you always have to make sure the 90 degree, the 0, like where it all intersects, need to be here. And then you're going to measure this line. Okay, so it starts from here all the way to this line here. And so so this is about, let me try to mark on it. So this is the angle I'm trying to mark. So this is about 40 degree. So you can notice that there's two measurements, a 40 and a 140. So you know this is not going to be 140. So it starts from 0, you go up, so 10, 20, 30. So it's 40, or it's probably 39 if you want to be very exact or precise, but that's how you use to measure an angle using a protractor, right? So in this case, we wanted to label each angle. So in this case, we're learning about classifying an angle, and you can see that there are different kind of angles. So you have one angle, and I'm sure you guys have seen this before. This is called acute angle. Okay, hold on. All right, so this is acute angle. And one property you need to remember about an acute angle is it is less than 90 degree. Than 90 degree. So a lot of times, I think the best way maybe to do it is, uh, Let me erase this part. And then to try to make sure we're writing with, so this is acute, where let's say this is an x, right? So x is less than 90 degree, and this is called acute. Okay, and then the next one is, as you guys can see, is x is equal to 90 degree, and this is called a right angle. When you see it a little bit bigger, when x is, it's between 90 is less than x and x is less than 180 degree, that means it's between the two, it's called obtuse. And when it is a straight line like this, where x is equals to 180 degree, it's called a straight line. Okay, straight angle or straight line. Okay, so that's what this is represented, a right, obtuse, acute. Okay, so just remember, obtuse is not equal to 90 or 180, it's in between. All right, the next learning target we're going to focus is I can use adjacent angles and linear pair to find the unknown measure. So what is an adjacent angle? That's a very good question, right? Because if I'm talking about something, you need to understand what the definition is. Share a common ray. So an adjacent is usually next to each other. That's the definition we use. If I say these two buildings are adjacent to each other, you know they are next to each other. But if I say they're opposite from each other, then you know they're opposite across from each other. So in this case, it says if P is the interior of RST, okay, P is the interior of RST, then angle RSP, angle RSP, and angle PST are called to be adjacent angles. So that means this angle and this angle here are called adjacent angles. Okay, they're adjacent angles. They are next to each other with a common ray, which is ST, right? That's the common ray. That's the common ray. That's the common SP. I'm sorry, SP. They both share line SP, as you guys can see. This is the common ray. Okay. The measure of RST is the measure of the adjacent angles. So the sum of the measure of the adjacent angle. So this is where we can talk about angle addition postulate. So RST, which is the whole thing, is going to be equal to, see how we have angle RSP plus the yellow one, which is angle PST. Okay, so the whole thing, which is the green one, is the sum of the measure of the purple one, RSP, plus the measure of PST, which is the yellow one. Okay, so now let's go to the next page where it talks about the angle addition postulate. So in this case, I know the angle here, which is angle TAR, and the angle, this angle here, which is CAR, are adjacent angles. So the measure of TAR is given to be 40 degree, right? So let me use. All right, so the TAR, which is the yellow one, is 40 degree, right? So I want it to be purple, no, yellow, sorry. So this is 40, right? And then The red one, I don't know what it is because the 120 is for the whole thing. So for the red one, I'm just going to label it as X. I don't know what that is. So this is my X. Okay. And then the whole thing, which is the black one, is, I don't know if this thing has a black color, but if not, I'll use, yeah, it does. Okay. 120 degree. So what we need to do is the measure, which is 40 plus X equals to 120. Then I can just do minus 40 from both sides, right? Then X would be 80. So the measure of CAR, so the red angle here, angle CAR, the measure of CAR equals to 80 degree. Because when I add 80 plus 40, it gives me 120 degree. Okay. All right, so it's kind of the same thing with the segment addition, but this is a little bit different. So I'm going to kind of guide you with example one, but I want you guys to kind of try it yourself. So, and every time you're given, and it's kind of better if you can kind of color code it what is given. And I have color pencils in a classroom that we can use, and that kind of helps us to see which one we're talking about. So the first one, the red one is RSP. RSP, which is this angle here, right, is given to be 2x plus 10. PST is the purple one. PST is this one, and it's given to be 3x minus 5. Okay? And then the blue one is the whole thing, and usually try to put it like this, is given, RST is given to be 85. Okay? So you can see by the angle addition postulate, I can take the measure of the red one, which is angle RSP, plus, so we can say the measure, plus the measure of the purple one, which is PST, and this is the angle symbol, equals to the blue one, angle, measure of angle RST. Okay, now if you put in what we have as a red, which is 2x plus 10 plus the purple one, which is 3x minus 5, which is the blue one, 85. Okay, so I need you to combine like terms and be able to do it, but we'll go over it more in class. Okay, good job. All right, the last part of this example, or is we're going to talk about I can identify adjacent angle and an angle bisector. Remember we talked about segment bisector last class. An angle bisector is a ray segment that line intersect. It's a ray or a segment or a line that intersect the vertex at an angle and cuts the links into two congruent parts. That's the key. Okay, the adjacent angle will have equal measure. That's what it's going to end up being. So when you see the word angle bisector, remember when we talked about midpoint, we have to set it equal to each other. That's what you have to do. Even if the picture does not look like it is an angle bisector, you always have to go by what is given. So in this case, given RQ is a bisector of PRS, that means it's going to cut this whole angle into two equal parts. So this whole angle is being cut by this ray. That means this segment here and this angle here are going to be the same. Even if it doesn't look like they are the same, right? That's what you have to do. So in this case, find the measure of PRQ. PRQ is this part. So drawing not to scale, so remember, okay? So since I know the word bisector is given, I am going to set the equation equal to each other. So I'll do y plus 40 equals 3y minus 20. Okay? That's the setup. So that's the key word you have to look. If it's an angle bisector, you set them equal to each other. If it is just an adjacent angle, you add them up, make it equal to the whole thing. Okay? So this is what we have to go over for Unit 1, Day 5. We'll go over more of the examples in class. Okay?